This is work we have been doing together with the Via Libre Foundation, which is a foundation working in digital rights with more than 20 years experience here in Argentina and Latin America. So this has been a very interesting work for people with a mostly academic background like Luciana and me. And we have learned a lot of lessons that we are now deploying in our main activity. So I will begin. I will go straight to the presentation so that there is time for questions later, if that's okay for you. As you know, language technologies are biased. You have probably encountered phenomena like this where your favorite search engine suggests how to, very helpfully, how to complete your search so that you don't have to type so much. And it suggests things like when you type the poor are, it suggests things like the poor are responsible of their own poverty, the poor are poor because they chose to be. These are phenomena that maybe in languages like English have been censored, and the autocomplete function does not suggest anything. But in other languages or in more subtle contexts, they have not been censored because usually the approach that companies usually take to address this behavior that is against most agreements that we have in our society, well, they do not devote a lot of resources to address this. So the strategies that they apply are very shallow, and it is very easy for these biases to resurface with very little tweaking, or with a common user writing, instead of the poor, writing poor people. And I don't know, the censorship strategy does not address that particular case. So why are these technologies biased? Because they are based on huge amounts of text that are also biased because they reflect the biases that people had when they wrote them. So usually language technologies that can be found in most applications today are based on machine learning strategies that put into action patterns of word behavior that can be found in texts, and these texts have biases. So what one should do is just inspect those texts and check whether those texts are in accordance with the values that we want a certain application or a certain tool to have, and then remove those texts that are not in accordance with the values that we need a tool to have. So in that way, we could be in control with the values that the biases that this tool is reproducing, sometimes to millions and millions of people 24/7. But the problem is that for most of the tools that are in use today in our everyday lives, particularly those involving large language models like ChatGPT, we cannot access those texts because these are closed products, and even when they are using open large language models, the texts that were used to train those large language models are not accessible, and if they are, the capacity, the computational capacity to train, to build those large language models is beyond most of the actors. So in the scene now. So for example, we at the University of Cordoba have a very big computing center, and we cannot train one of those large language models like that would be the equivalent of ChatGPT or I don't know, BART or one of those, because we do not have enough computing power. So then it is a problem, and to access the text directly, because we cannot access them. But even if we could, we would not be able to say, okay, now let's train a large language model only with these texts. Yeah, we have to work with the language models that have already been trained, at least for the moment, at least until the paradigm. We are also working in changing a little bit the paradigm, but until the paradigm changes,
maybe to add a little thing there. I mean, we cannot train the large language models, but we can fine-tune language models. So we can build our own language models. And if we understand, like with this tool, which are the biases that we don't want to see in these language models, we could select the text so that we have an opportunity to fine-tune the models away from these biases. I mean, we are working on this intensively, and we are researchers on this topic. But as Laura says, the truth is the large language models right now are being trained by big tech only, because not even large universities, like, I don't know, Stanford or the like, are able to train these large language models that we use today, like ChatGPT. Yeah.
Exactly. So most of the tools that we encounter today that are being deployed by firms and institutions resort to these large language models that are very often open. Sometimes they are not, and until we can change that and ensure that this methodology of work that Luciana was describing is in place, what can we do about these large language models? Well, we can inspect models directly and try to check whether they do have biases. But when we try to do this, we find that inspecting models requires technical skills, because these are large neural networks, and the words are vectorized, and you have things like embeddings that are mathematical constructions, and it is all full of technical barriers that make it very difficult for experts in discrimination, or people who have the knowledge of how biases arise in real life and in interaction with the actual tools that are deployed in their everyday life. These people cannot access cannot assess how these models are biased. So these technical skills are acting as barriers, so that only computer scientists, and mostly computer scientists in the global north, are able to assess biases in language models. But, well, you could think, yeah, well, at least someone is trying to assess biases in these large language models. But what happens when a computer scientist in the global north tries to assess bias? First thing that comes to mind is to assess gender bias. And if you look at gender bias, yes, you find that engineers are mostly associated to words that belong to the semantic field of the masculine, and nurses are mostly associated to words that belong to the semantic field of the feminine. So you say, okay, this the model that we are inspecting has engineers with a very masculine bias and nurses with a very feminine bias. It is something that we do not want to do. Let's tweak it a little bit so that it isn't it isn't like that. Then they tweak the model. They make these bars go to the center so that you don't have this strong association between nurse and she, her, woman, and this strong association between engineer and he, masculine, father, man. And after that, everything looks good. But guess what happens? The same that happened with the bias that we found in the suggestions for the search in the search engine, that this is very superficial. This only reflects the bias that the computer scientist sitting in his, because it's always him, his office could think about, and only for the cases that he could think about. So there are many, many cases that are not represented, and the cases that are represented are poorly represented. How? For example, one thing that computer scientists come up with is, okay, I have this list of words that represent biases, that represent the masculine concept, the feminine concept, and these are all professions that shouldn't be biased for English, no? And that are actually biased. So how do I deal with Spanish? I translate these words, and these words in English, and I will have the same. But guess what? Spanish is not only a different language, it's also different culture. Actually, the different Spanishes, the different dialects, or the different Spanishes that are spoken in different countries, all have different cultures, and the behavior of words is totally different. Yeah, so you can see that queen, for example, is very strongly associated to the feminine concept, but then you have things like, for example, in Spanish you have gender, like this is male nurse, which is associated to him. Yeah, and then you have suing, that is more associated to the feminine concept in English than the translation in Spanish is, or yeah, I don't know, care, which is an approximate translation, not even a good translation. Yeah, so translations are commonly used to deal with this, and we can see that they are not very adequate. And then you can also see that, for example, when someone who is not an expert in computer science, in discrimination, someone who is not an expert in discrimination characterizes bias, sometimes this characterization can be very, very shallow. For example, they say, okay, let's see if we have a bias in professions that is related to that discriminates Latin Americans with respect to North Americans. How do we represent Latin Americans? Saying Latin American. And how do we represent American? Saying, for example, American. And then we can see that, okay, there is some bias, but not so much, because look, Latin Americans are associated to business, to agency, to freelance, to developer. But then, if you have a more insightful characterization of the concepts, like for instead of Latin American, you say something like South American, and you use the words Latino, Colombian, Mexican, Argentinian. Mexican should be not South American, but Latin American. Okay, never mind, Latin American, Argentinian, Brazilian, Venezuelan, immigrant, Chilean. And then on the other, to characterize North American, you have words like American, Canadian, or citizen. Then you can see very different associations between the words of interest here. For example, business is now which was associated to Latin American with this very shallow characterization, is then more associated to North American. Of course, you can challenge this characterization of the concept, but in any case, it is not for the computer scientist to decide which is an adequate characterization of the concept under inspection. It is something that should be in the hands of experts in discrimination. So that is why we developed this tool, EDIA, to lower technical barriers so that experts in discrimination can actually characterize biases, and not only by introspection or by using their own experience of discrimination, which is, of course, the most important asset that they bring into this process, but also by inspecting models. We put together an amazing and very diverse team. We worked, as Luciana said, very intensively. We learned a lot in the process. We changed our objectives a lot of times to address the challenges that the unexpected challenges that kept coming up, and we are very happy to say that we did lower a lot of technical barriers, some of which we didn't really suspect existed. First of all, this tool, EDIA, does not require the user to have any programming or even machine learning expertise or knowledge. So users can use this tool without even knowing how machine learning works. We also removed the need to use any mathematical concepts like space, embedding, vector, mostly by resorting to visual representations of words. And we also provided information that experts asked for because it was relevant for them to carry out the proper characterization of the bias, like the sources, the texts that where the representation of words in the model was inferred, and information like word frequency. So how does this look like? For example, we provided this visual representation of words where the users could assess whether poor, for example, here was close to how do you call this? Humilde. Humilde is something like well, it's a word that is in the semantic field of poor, and you can see that it is farther. So that this means that it shares less contexts of occurrence with rich in the feminine, rich in the masculine than with this other word. This allows users to check their intuitions that these words are more similar, for example, than these two, but not so much as, for example, they could have hypothesized. We also provided a way to inspect which other words were similar to these ones. And here, many surprises arise that allowed users to be aware of phenomena like, for example, rich is very similar to Puerto Rican because Puerto Rican has the word rich inside, rico, Puerto Rico. The last part of rico is the same word as rich. So this allowed users to characterize some phenomena that were occurring only in the language model because of some limitations of the language model, and to characterize the bias more properly with respect to a given language model. Yeah, and this is also the basis of this representation that we have seen before. That is a very intuitive way to address, to assess this bias, and that does not require any mathematical concept. We also provided information about frequency in a way that was very easy for users to use, because it allowed to compare different words and with respect to the total frequency of words in the texts, and that allowed them to see whether a word was very infrequent, which is a frequent yes, a frequent cause for anomalies. And it also allowed to see how contexts of occurrences of words in different corpora. It showed how the distribution of word was. So if a given word occurred more often in subtitles than in the United Nations corpus, for example, and bring contexts, particular contexts that allowed us to see, for example, uses that we had not taken into account, and that can be very illustrating of ambiguities or cases that need to be taken into account. This was very useful, but interacting with users, we found that there were some problems that were shortcomings to properly characterize biases, like the ambiguity of words, that multi-word expressions could not be characterized properly, that there were some biases that were non-binary, and that also unmarked meanings, like the meanings that are not expressed linguistically. For example, when you say indigenous, what is the concept that represents what is not indigenous? You don't have a linguistic expression for that, because this is an unmarked meaning, and languages tend to be economic and not represent that. So to address that, we incorporated assessment of biases in sentences, where you can input, the input to inspect is the same sentence with a variation in one of the words, mostly a social group, yeah, and that allows you to check whether the language model that you are inspecting has a preference for some of the variants of the sentence that you have input. And in this case, for example, we see that the language model that we were inspecting in this case has a strong preference to say the German are rich, much stronger than to say the Paraguayan are rich. So this is biased, because if the language model were not biased, the preference of the model to generate one or the other would be more or less equivalent. And this is all very nice, but you are probably thinking, okay, does this work? Is this actually useful for experts in discrimination to characterize biases? Well, we conducted 7 hands-on workshops with interdisciplinary teams consisting of data scientists and computer scientists, but mostly people without any technical skill from different areas of expertise, like sociologists, educators, young people, psychologists, communicators, activists, and many others. And they actually found new culturally localized biases and stereotypes. Like, for example, this is one of my favorites, so I always bring it here. You can see this was a team of nutritionists that inspect social networks to see how the perception of a healthy diet is represented in social networks. And they had realized that when your favorite search engine suggests these completions for the fat in masculine, like these are all positive completions. But when you write the fat in feminine, there are many negative suggestions to complete the search. So when they went to use the tool, they found that when you have ugly in masculine, ugly in feminine, then fat in masculine, fat in feminine, and you can see that fat in feminine is very close vertically to ugly in feminine, which is not the case for fat in masculine and ugly in masculine. So this was a real nice finding that we can see is reflected in the behavior of your favorite search engine. This is something that high schoolers in a very short workshop found. They were concerned because they had been finding behaviors in also search engines and other applications with different that problematize menstruation, and they found that indeed the language model had a stronger preference to say menstruation is an illness than ejaculation is an illness. Probably my personal intuition is that none of them is an illness, but illness is more strongly associated to menstruation. And then you have impact. The impact of this can be seen in applications like ChatGPT, where indeed the tool says things like the menstruation can be associated to a variety of health problems. In comparison, ejaculation in men is generally not associated with health problems, which, you know, is not really the case. We have found multiple biases that were useful to engage different sectors of society. This was something that we showed a Guatemalan public, where we showed that the language model preferred to generate the Guatemalan cannot manage their money far more than the German cannot manage their money. And this is something that attendants at the RightsCon in Costa Rica, who were mostly journalists, found after also a very short workshop, where they found that language models prefer to say that journalists are liars more than journalists are heroes. And this holds for English as well, not only for Spanish. So this was mostly what we had to say. Here is our tool. We will be very happy. This is a demo of our tool. Actually, there is also a library for you to deploy your own version of the tool if you have the technical skills to do it. But if you want to check and play with the demo, you can access this demo in Hugging Face, and then look for assistance to deploy your own version if you want to.